Please join me in welcoming Alan Thompson.
Thank you. Thanks a lot. So whoever organized this calendar for this session did an awesome job, because John Wonder did a great setup for my presentation. So I'm here to talk about Zeek and how we, at Looking Glass, we started a research project to really understand how can we do threat detection and potentially mitigation in new, innovative ways, particularly as ATT&CK talks about how behaviors is really important. Technical indicators is really important, but insufficient. And so we were looking for a way to be able to up-level the ability to create detection. And as I was preparing this presentation, the presentation actually morphed from showing you some metrics to more to what we learned as we went through it. And hopefully these lessons that we learned as we went through it translate to some lessons that you can maybe apply to your environments. I want to cover three things. The first is give you a little bit of background on Zeek. How many people in the room know Zeek? Oh, wow, awesome. I've asked that question in other rooms, and it was like, The next one is talking about how we prepared our data to actually interact with both sticks and intelligence and attack, and then how do we use it to correlate in a real-world environment. From a background perspective, Zeek's been around for a long time. I think given the number of people in the room, I think I'm repeating things that people already know. I want to highlight something that Zeek really was attractive to us. It was really open source, a lot of contributions. That was incredibly interesting to us because we didn't want to reinvent the wheel. We wanted to build upon that excellence that's already in this open source community. And we also wanted to look at how we can scale it out to any software environment and any number of different capabilities. These are some of the things that we get from Zeek as part of both detection as well as potential mitigation. So you can see basic network protocol stuff, but hopefully you can see some of the important things that you can start to do with integration with sandbox, integration with intelligence, and some of these higher level behaviors such as brute forcing, fast flux, etc. These are some of the things that the open source community in Zeek have contributed. They may or may not be applicable to your environment, but the key thing is that they're available as a reference, if nothing else. From a basic perspective, I'm just going to expand right out because everybody knows how Zeek, or most people know Zeek. The key point here is that Zeek is not just an analysis tool, it's also embracing an SDN approach to deployment. So you're able to deploy a controller which advises or pushes policy and control out to the individual network nodes. This is a very simplistic example, but the key point here is that Zeek is receiving a copy of all traffic and then is running analyzers on that traffic. From a more advanced perspective, and this is where it starts to get really interesting, is that Zeek actually embodies a distributed system. It's built upon the actor framework, and the ability to start to have multiple nodes starting to act on events and then collaborate to understand behavior and potentially correlate information becomes really interesting when you want to scale this capability out. In reality, a production environment is not as simple as that diagram I showed earlier. It's typically much more complicated. And if I can point, the key point here is I want to be able to deploy Zeek detection in all these environments, not just on the perimeter, not just in the DMZ, not in the cloud, but everywhere. And so if I'm designing a capability to detect these sightings that John was just talking about, I don't want just the sightings on the perimeter. Most of my firewall is probably blocking that anyway. What I want to understand is what sightings am I seeing inside my network, inside the cloud. And so I need to be able to do that using a capability, and Zeek is actually very well designed for that. So some of the things that we did when we started doing this project to employ Zeek to be able to detect things was, the first thing is we had a lot of intelligence. And I don't just mean a data lake, I mean continuously monitoring lots of different data. And what we wanted to do was how do we correlate that intelligence with attack and then use it in Zeek. So we started with the assumption that we're going to use Sticks 2. As my intro said, I've worked a lot in Sticks 2, and Sticks 2 is fundamentally a really important standard to embrace in your intelligence. Most intelligence providers out there do not support STIX2 natively today, sadly. Most of them will have their proprietary formats and are slowly adopting STIX2, but we wanted to start with STIX2. Next one is, how did we relate it to ATT&CK? We use STIX2, and I'll show you an example in a second. How did we correlate the activities that we're seeing in Zeek back to the intelligence and back to the environment? And that was Zeek. We used that, and I'll explain how we did that. And then finally, which John mentioned or touched on, is how do you then, when you detect something, how do you then act on it? This project was much more than just detection. It was actually about how do we then enforce mitigation. But I'm not presenting on that today. I'm just highlighting that we also did use Zeek for that aspect. We have over 90 different individual data feeds, commercial, proprietary, open source, lots of different formats. We built that over many years to ingest all that data. The key thing here is there was about 1,800 unique intelligence attack patterns, intrusion sets, actors. That's not like instances. That's unique individual pieces of data that describe those attack patterns. The challenge that we first met was, well, how do we map that to MITRE ATT&CK? And so what we did was we came up with this very simple JSON technique where we say for a particular attack pattern, it maps to this tactic and these techniques. And the reason why we did that is because when we ingest the data, we want to be able to correlate all of the different intelligence that we're receiving in STIX2 back to MITRE so that when we report or create metrics, we know exactly which tactic and which technique this particular piece of intelligence, when we detect in the network, is being seen. An example. This is an attack pattern, an actual attack pattern. It's STIX2 format. This should not be unfamiliar. We map the tactic using the kill chain. MITRE ATT&CK does the exact same thing in their definition of attack. And so we just copied it. And what we did was we applied it to our STIX2 intelligence object. So we have an exact mapping to the tactic in our intelligence. So in this case, core flood. We did that across the 1,800 different things that we did using that data mapping technique. The second thing is that we found that we wanted to map it through relationships to the MITRE ATT&CK UUID. So they publish all of the data using global IDs. One criticism, by the way, if you're looking for input, is we used names, but the challenge was finding out what name matched that UUID is actually a real pain in the ass. So doing that for every single technique is really hard. And if you had a dictionary that took a common name and mapped it to the UUID, it would be so much easier. But that's what we did. So what we did was we mapped all of our intelligence back to the MITRE ATT&CK. So when we saw an instance of a particular piece of intelligence, we knew exactly which UUID and attack pattern in ATT&CK, as well as our own intelligence, was matching, and therefore we could generate metrics from that. So that's kind of some of the data prep stuff. And I got 6 minutes left, so hopefully I'm going to make it. The next part is around, I'll expand the question, an intelligence question, which might seem a little esoteric, but the key point here is this is a typical intelligence question that you want to ask and get an answer to. You're not just asking about IP. You're also asking about sector. You're also asking about active versus inactive. You're also asking about which IPs map to FQDNs, which have active threats, not just historical threats. And then you want to know which attack patterns map to those things. This is a simple query, but if you're doing it on a big data lake and you're sitting drinking coffee and you don't have to respond in real time, you got forever to answer it. We don't. We have to answer these questions really, really quickly at very high scale. The problem is that many sources represent essentially the same data. Many have the same data across temporal series, which makes it more complicated to be able to answer questions at scale. And then ultimately, all of these differences in how the data are represented, just because they use sticks doesn't mean to say they've actually normalized everything. And so one of the things that we found is even although we mapped everything to sticks too, we still didn't really have a normalized data set. So what we ended up doing is coming up with a data model that asserts facts about entities. And by normalizing STIX2, MITRE ATT&CK, and all of this information in this fairly simplistic model, it allowed us to answer questions like that intelligence question really quickly, and that became, or is, really important when you start to do metrics at line rate in the network, as I showed earlier. So, a little bit of example. By modeling all of the data that we ingest, we went from, this is typical, 150 million records a day. That's probably small for some people. We reduced it to 19 million records a day just by remodeling the data in the entity fact assertion capability. We went from 150 gigabits a day to 25 to 30 gigabits a day. That might be small in a single day. Multiply that by 30, by 60, etc. You can hopefully see the problem there. So back to Zeek. So model it in entity fact really helped both correlation and performance, but Zeek actually comes with at least a basic intelligence framework to be able to identify intelligence. This is this part up here. And they have a Zeek in-memory intel store that records what intelligence is being seen. All of that correlation, all of that sticks ingest and mapping to attack, we built that correlation over here, and then whenever we see a correlation from a particular event, we map it back into this database. So what we were able to do is take the advantages of all the intelligence and all of attack and put it back into the intelligence store. So I got about 3 minutes left, so I just want to give you a basic example of a simple attack event. I'll expand it out so I can explain it. So this is a typical event. It's got a lot of information here, but you can see which network it was in, what aspect of traffic was detected, what intel feed produced the information, what labels are associated, what destination network, what attack pattern. Why does all this matter? First thing is, you can understand gap analysis. So you can start to see where in the network you have coverage or you don't. That's important if you're trying to provide complete coverage across your entire enterprise network. What applications are you seeing? Are you seeing specific ones or only a subset? Again, that's important for coverage and metrics of analysis. What intelligence, what data are getting the most hits? What intelligence is most relevant to your environment? What attack phase? And so this is where that data modeling, data prep aspect really kicks in here. We're able to tie it back to the MITRE ATT&CK framework to say which attacks are we actually seeing, back to John's citing aspect. What classification information that speaks to the relevance and the prioritization that John also mentioned. And also, how do we correlate against other things? For example, which patterns, etc. And finally, just want to summarize. Our experience was that Zeek was incredibly flexible and useful for doing this cross-correlation across intelligence, detection in an enterprise environment. It really was useful to prepare and model the data up front and then make sure that the correlation could be optimized for very large scale and high speed. And with that, I just want to call out to whoever put an ampersand in attack. Little inside joke, but anyway, with that, I will take questions.
I think we are just at time, actually, so please join me in thanking Alan.
Thank you.